Don't believe it, just watch. Don't believe it, just watch. Don't believe it, just watch. Don't believe it, just watch.
Hey everyone, it's Sound Guy Barry. I was recently asked a question, which is, what amplifier should I buy? Are the lightweight digital amplifiers better? I thought that was a great question, so I thought I'd give you my thoughts on the topic. And I'm of two minds. On one side, I'm a sound guy doing sound for touring bands, and on the other side, I'm an audiophile. And depending upon what my application is, my opinion varies. So as a sound guy working with touring bands, I'm a big fan of the lightweight digital amplifiers because they're lightweight. Hauling that equipment around can be a real back-breaking experience, especially with your amplifiers weighing 50 pounds or more. And you can get the same amount of power in a box that's maybe 10 pounds, and that's fantastic. And I would say, as a sound guy, that amplifier design is a pretty mature technology these days, and if you purchase an amplifier from a reputable company, it's going to sound good. So I've got quite a bit of confidence that if I get an amplifier from somebody like QSC or Crown, Yamaha, it's going to sound good. And I'm also concerned about reliability because I want to make sure that I don't have a show failure. That would be a really bad day. And if an amplifier fails, depending upon which way things go down, it might blow up the speakers that are attached to it, and that would be a really bad day. But amplifiers from reputable companies tend to be extremely reliable, and so if I was to choose a PA amplifier, I would give serious consideration to the lightweight digital amplifiers that are available. And we see that in a lot of powered loudspeakers. They're almost all digital these days. And just basically the weight savings alone makes it compelling. Another compelling feature is that the digital amplifiers run about 90% efficient, so that the power that you get from your wall socket gets converted into sound, or into power to drive your loudspeakers, which then makes sound, very efficiently. So the amplifier does not get hot, and you can utilize just a little more power from the wall. A digital amplifier runs 95% efficient or thereabouts, whereas a traditional Class AB amplifier will give you about 65% efficiency. So that's pretty significant in terms of making sound, not heat. Now, having said that, if I was a audiophile, I would then counter it by saying that, well, all amplifiers sound good, but they don't all sound equal. And some actually do sound a little better than others. Now, the differences are slight. They're pretty subtle, but I do think there are differences in the sound of different amplifiers. And I do think that, generally speaking, most of the time, the linear Class AB amplifiers sound better than the digital amplifiers. And I think this is primarily because in the digital amplifiers, they have to go through an output filter stage to convert the digital pulses within the amplifier back into linear audio to drive your speakers. And that filter stage has some interaction with the load that you apply to the amplifier. Speakers are not a pure resistive load, they're somewhat reactive, and that can interact a little bit with that output stage filtering, so that different speakers on digital amplifiers will have a little bit different characteristics, and that's not so much the case with a linear Class AB series amplifier. They tend to be more consistent no matter what they're driving. And another thing to consider is, if I was using an amplifier for home hi-fi use or within the studio, the noise of the amplifier mechanically is really important. So I would choose one that has no fans, or if it does have fans, they are controlled thermally so that the fans are turned off during periods when you're not stressing the amplifier too much, and they're quiet fans that you don't hear over the program material when it's being played back. If I was choosing an amplifier for the band, for PA sound, I'm not too concerned about fan noise because you'll never hear it over the ruckus of the band. And in fact, I might like an amplifier with plenty of fan because it's going to be driven very hard in those applications generally. And I want to make sure that the system has enough thermal capacity so it can handle it. So those are my real quick thoughts on it. Let's talk just a little bit more about how the amplifier works and the differences between Class AB or Class H amplifiers and the digital amplifiers. All amplifiers are made up of basically two modules, the power supply and the amplifier electronics. And this here is a old Crown amplifier, great stuff. And this is a pretty small amp, of course. It's about 50 watts per channel. And it's a good example. And so right here on the top side we have the power supply, which consists of this transformer, which is a couple windings away around an iron core. And the transformer transforms the input power to the voltage that's needed by the electronics in here. So it steps up or steps down the voltage as necessary for the electronics within the amplifier. Most amplifiers, it steps it down because we don't need as much voltage as what's coming in off the line. And the transformer is a couple of windings on an iron core, and so this is probably one of the heaviest components within the amplifier. After the voltage passes through the transformer and gets scaled correctly, it then goes through a rectifier stage to make it from AC voltage, which means it's swinging plus and minus 60 times a second, or if you're in Europe, 50 times a second, into pure DC, which is more like a battery. So it's always just going one direction, it's not swinging up and down. And then those pulses of DC are stored into a bank of filter capacitors, which you can see right here, these big tank-like things. And so that smooths out the power. So we have nice, clean, pure power without any little spikes or glitches on it. Almost like if it was coming off of a battery, if you will. You can think of the capacitors kind of like a town water tower. So you can pump water into the water tower in pulses, but as the residents demand water, they have a nice, smooth, steady stream of readily available power. So that's what these capacitors are doing for you. Now, there's two types of common power supplies. This is a linear power supply, which is what comprises the weight of most of the traditional amplifiers because of this big heavy transformer. There are also switching power supplies, which are the kind of power supplies you find in a lot of computer equipment. And what they do is, as soon as the power comes into the power supply, there's basically a switch, transistorized switch, that chops up that power many, many times a second, maybe 100,000 times a second. So we have this very high frequency pulse train coming out. Now, with that really high frequency train of pulses, we can run that through a transformer to step up or step down the voltage, and then that passes on to the filtering just like it did in this Crown amplifier. Now, by doing a high frequency pulse train rather than just relying upon the power line 60 cycle undulations, we can use a much smaller transformer. Higher frequencies usually mean smaller components, kind of like in your loudspeaker system where the low frequencies require these big heavy-duty woofers, whereas the high frequencies are just smaller tweeters. Kind of the same thing with your transformer. So we can use a much smaller transformer to couple that power, and then again we have the bank of capacitors and so forth. And so by using a much smaller transformer, the amplifier is much lighter than it would be with a big transformer. Now the downside of this is that the switching power supply is a more complicated design, and if there's a failure it's a little more challenging to fix. The upside is that it's more efficient. It can pass more energy through the power supply than you could with the traditional design. And so in a digital amplifier you'll almost always find switching power supplies, which are much lighter in weight. And you can sometimes find switching power supplies in traditional amplifiers too. For example, the Yamaha P-series amplifiers, which I think are great amplifiers, and they use a switching type power supply which keeps the weight down and the efficiency up. They're, for example, a P5000S amplifier is 500 watts per channel to 8 ohms, and it's only a little over 20 pounds. The P-Series amplifiers, by the way, also have very quiet fans, so they're good for studio type use or PA use. And I'm not here to recommend any particular product, it's just one of those that I tend to like. Then the other section of the amplifier would be the amplifier itself, which in this one would consist of, make sure I'm on camera for you, this board right here, which is all the small signal stuff. And then we have a series of output transistors here. This amplifier has 4 transistors, 2 for each channel. That's pretty typical. If it was a bigger amplifier with more power, you'd probably have more output transistors. And the transistors act kind of like a water valve, where you've got a control line, which would be the handle, and then you have power that can pass through the device. And so by providing a little bit of control signal, it opens or closes that valve to let more or less electricity pass through the transistor. In a Class AB amplifier, traditional amplifier, the amplifier is about 65% efficient, and so 65% or so of the power goes through that transistor and out to your speakers to make noise, and 30% of it goes up as heat. And that heat must be dissipated by big heat sinks and or fans. And so that's how traditional amplifier works, Class AB. Now some amplifiers are labeled Class H, possibly Class G, and what these are is they're really just a traditional amplifier, just like we talked about, except that the power supply has got multiple steps to it. So it can run in low power mode when the signals are not real high, and as you turn the volume up and more is demanded out of the amplifier quickly switches up to a high power mode and then provides the energy that you need to keep up with the signal that you're driving into it. So you could think of these kind of like some of those cars that are able to run on, all 8 cylinders of their engine when it's necessary, but if you're just cruising down the road and not demanding much power, it can shut down half of the engine for more efficiency. That's kind of like a Class G or Class H amplifier. Now the other kind of amplifiers, which are a whole different animal, would be digital amplifiers or Class D. And how they work is they don't use these transistors as a variable valve. They actually switch things on or off. So for example, if you wanted to have a light which had a dimmer on it, you can have a variable dimmer to control the amount of power going to the light between off or fully bright. Or instead of using a dimmer, you could just use a switch. And if you wanted the light off, you turn the switch off. If you wanted it on, you turn it on. And if you wanted the light at half brightness, you could just flip the switch very fast, so it's on half the time and off of half the time, and the light would appear kind of half dim, wouldn't it? Especially if you kind of filter out the energy. So if you're giving the stream of pulses going bang, bang, bang into the light, and you filter it a little bit, if you only turned it on half the time, it was off half the time, well, you get half the power. If you had the thing turned on 3/4 of the time and off 25% of the time, well, then the power level overall coming through would be 75%. And so if we can switch the amplifier much, much faster than the audio signal comes through, we can create a series of pulses that equate power-wise to the audio signal as it's flowing through the amplifier. So we have a set of transistors in a switching amplifier, or Class D amplifier, but they're not variable in power. They're just switching completely on or completely off extremely rapidly to provide a train of pulses that equal the amount of energy necessary to follow the audio as it goes through the amplifier. And by doing these hard switches, either all off or all on, that's really efficient. And so a digital amplifier can run efficiencies of 95% or better. Now after we get this high frequency pulse train coming through, we need to put it through just a little bit of filtering to smooth all of that out so we get nice smooth audio on the back side. And so there's just a filter circuit after the switching transistors to convert that pulse train back into normal audio that drives your loudspeakers. And designing that filter so it works right is a little bit of an engineering challenge. But, we have mature designs that work well now. But that filter has a little bit of interaction with the characteristics of the load. And because of that, speaking as an audiophile, I don't like to use Class D amplifiers. But speaking as a PA sound guy, I still think that those amplifiers sound just fine, especially in that context. And the efficiency gains and the lightweight is certainly compelling. So I hope that answers your question. I'm not here to recommend any particular amplifiers, but I hope that gives you a little bit of insight as to the applications I would use for a standard, traditional, linear amplifier versus Class D digital amp. And I'd like to say that there's a lot of great products out there, and I would recommend that you stick with a respected manufacturer because reliability is really paramount, and if you have any equipment failures during a show, it's not pleasant at all. So I hope that you can make a good choice that works well for you. And I hope that one of those choices is catching my next episode of Sound Advice. I appreciate you sticking around, and I'll talk to you next time. Once again, my name is Barry. I'm a sound engineer in the Minneapolis-St. Paul, Twin Cities area. If you have anything that you'd like me to address or questions, I'd certainly like to hear them. Feel free to leave a comment below. And if you have anything you'd like to add to this, again, feel free to leave a comment. And I'll catch you next time on an upcoming episode of Sound Advice.